Welcome to another episode of Flutter Original Show. This time I have one of the authors that I used to have it in my channel, and for this show talking about another package, Hive. Simon is with me today again. Well, he promised and he made it to talk about Isar. I am very excited because he recently made good update to Isar, and it's so tempting to see what he has done because the benchmark he showed, you don't know, you will see it very shortly. It's so promising. And well, why also Isar is important? Isar is a database, NoSQL style. It's if you're building any type of application, you probably need some kind of database to store your local data or like query and do stuff, especially if you are making offline first application, and I think one of the best solution right now there is Isar. And let's welcome Simon. And Simon, how's it going?
Hey, Hachid, it's so cool to be here again. I'm good.
Nice. Thank you for joining again. And let's quickly introduce yourself because so many new visitor or like viewers of the channel may not have seen you before. Who you are? What are you doing?
I'm a Flutter engineer from Munich, Germany. And in my free time, I try to build open source packages, stuff I'm excited about, and mainly databases because they fascinate me for some reason.
It seems like you are very expert on that because you have a bunch of packages that it's all around databases. So Hive was one of them in this channel.
Yeah,
and
it
another
happened
one
over
is
time.
Isar. Yeah, of course.
Do
Do you wanna
quickly?
quickly? Yeah. Do you wanna explain quickly what is Isar and what is Hive? I think these are the two main packages that we're gonna talk about it today, and what makes Isar like exceptional, like compared to Hive, and then things that are related. Go ahead, the stage is yours. Tell us about these two packages.
Okay, so I'll start with Hive. It's a very simple key value database. It's entirely written in Dart, and it uses its own storage format to store your contents on the disk. But it has some problems. Mainly, it does not support multiple isolates. It can be slow at times, especially at app startup. It doesn't support queries well, so you have to implement them in Dart, which can also be slow. And it doesn't have indexes. Basically, it's a simple database, but if you have advanced needs, I don't know, build a chat application, build an email client, task management system, anything like that, you likely are looking for something more advanced, like SQLite. But the problem with SQLite again is I find it a little difficult to use. And I just wanted to build something that is really fun to use, really fast. You cannot make a lot of mistakes. And I hope to provide good documentation and just make a system that works perfectly well for Flutter. That was my initial goal with Isar.
And I think you made it. So I'm in love with Isar, and that's one of the. And also, you are a fantastic community contributor and also author. So that's why you're here, and we're talking right now about Isar to make others. You're making other developers' life easier by building these packages. So Isar, let's talk about that. You said it's a similar to SQLite and NoSQL probably approach database, right? Do you want to explain about that? Like for those who actually have not used any NoSQL or even SQLite, do you want to say
Sure.
something about that?
Sure. So Isar is made of three components, basically. There is Isar core, which is the backend that is written in Rust. It takes care of all the heavy lifting. It executes your queries, stores your data, manages different threads, and all this fun stuff. Then there is the Isar generator. It basically looks at your code at build time. It analyzes your Isar classes, and it builds code that allows you to interact with Isar core in a really easy way. And it makes sure that at compile time that you're not making any bad mistakes. And then there is the Isar package itself, which at runtime is a lightweight layer around Isar core that helps you talk to it. And the difference to SQLite, for example, is you don't need to care about your schemas for your tables. You will not have to write queries using strings. And instead, it's more like object builder style with static extension methods that prevents you from making any mistakes as good as it's possible.
That sounds good. One of the interesting thing about Isar that fascinated me as well is that you used Rust to get the best performance for your database. You want to quickly open up the repo of Isar and just walk us through what you've done there very quickly.
Yeah. So let's first look at Isar core, the Rust backend. Oh, first we have to mention one new feature of Isar version 4. So in the past, Isar had a native custom storage solution. But with version 4, there's a new SQLite storage solution. So all the features you know from Isar before still work, but now you get to choose whether you want to use the Isar native engine or you just want a wrapper around SQLite. For example, if you want to use the same database from native context, from Android widgets, for example, and from Dart, then you just choose the SQLite engine and you get a regular SQLite file that you can just use from Android.
So what you're saying is like Isar is kind of like backward compatible with SQLite like databases as well. Like if I have already SQLite, I can actually hook it into Isar and also use maybe native engine of it, right?
Yeah, you can do that. It always.
But when you say that, also one more question. Sorry, go ahead.
No, sorry.
Another question is then in this case, that means am I going to have SQL queries and stuff like that, or still I'm gonna stick to the NoSQL approach? So how does that work when I have a
So you only change a single line of code in your code base to switch between the new two engines. All the other stuff works exactly the same. And the Isar core SQLite engine just converts your NoSQL queries and tables to a SQLite format.
That sounds good. Let's go through this native part, the Rust part.
So let's look at the interfaces. Basically, everything in Isar resolves around the instance. An instance is basically a database file. And it has a name, directory, and so on. And it supports transactions. So you can start read and write transactions to have an atomic view on your database. You can start cursors to quickly iterate through your database. You can insert and update stuff. And the cool thing, my favorite part, is queries, of course. And if we take a look at how queries work in the native instance, for example, here we go. This is all the boring stuff. Here, the Isar core supports these different filters, basically. For each type, there's a between query, then strings have some extra ones. Lists can compare any item is between a specific condition. And then there is stuff like nested queries. If you have embedded objects, Isar supports basically to store a tree of objects, and you can query nested fields. And then, of course, regular AND or NOT conditions. And all of these are implemented in this file. So if anyone is interested, it's actually much easier than you would imagine. Just go to the native filters file.
That's interesting. So that Rust package that you've created, how do you communicate it with the Dart layer or Flutter layer?
Yeah. So in the beginning, Dart FFI, that's what
Mm-hmm.
the interface you use to communicate with native code is called. It was a big pain,
Mm-hmm.
but
Yeah.
the team has done a great job, the Flutter and Dart team. And now it's actually really easy to use. There is great documentation, and a really cool thing, there is FFI Gen, I think it's called, and
Yeah.
it generates the bindings to call native code. So if we look at
Mm-hmm.
this, these are the bindings generated by Dart FFI Gen, and they call the Rust functions. If we search for query function, for example. Yeah, here.
Mm-hmm.
So this one iterates the query and gets the next object. And this code is horrible to write, and it's so easy to make a mistake. But FFIGen just generates it for you, and then you just have to call this function, and it calls your native Rust or C or whatever function.
Mm-hmm. But that, yeah, of course, this is one of the interesting features that was added to, I think, Dart 3 at least
Yeah,
for stable, the stable Dart 3. And so that means your package is also compatible with Dart 3, right? So,
yeah,
okay, that's very cool. I think one of the interesting thing about this architecture that you showed us right now, I think one of the benefit that I've seen is the huge performance gain. You want to show the benchmark that you've made so people get some feeling of like how fast is Isar?
yeah. But first, I have to put like a disclaimer.
Yes, of
Benchmarking
course.
benchmarking databases is super difficult and most of the time just unfair, because different databases have different capabilities and you never can 100% compare them. So I recommend to choose a database and see how it works for your workload. And only if it's too slow, choose another one.
Yeah.
That being said, Isar does pretty well in most use cases. As you can see, for inserting and querying, it's especially fast compared to like the most common competitors. Like I said, it's not only always a fair comparison, but I try to be as objective as possible. And as you can see, even the Isar SQLite engine is quite fast, which I found pretty shocking. But
Yeah.
yeah. And I also tried to make the Isar storage format really compact. So ideally, it should always use like 30% less storage than other databases. Apparently, SQLite is even better though.
Mm-hmm. How did you make this benchmark? Anyway, do you use any framework or anything, or it's like a manual tests by yourself?
No, it's just different queries that are executed
Okay.
100 times or so, and then I measure the time, and
Yeah.
I think it's here. Yeah.
Yeah. Sounds good. Sounds good. One last question about Isar, and then let's get to the implementation part of it, the fun part, pair
Yeah.
programming. So the Isar right now is a database that you target. You're targeting Flutter applications. Does it mean it doesn't work on Dart? Because Dart backend is growing, and I guess having actually a database in backend, well, some kind of maybe caching mechanism or stuff like that, it always makes sense and it's always needed. Does it work on backend too, like a pure Dart application?
That's a great question. So yes and no. If we look at the repository again, by default, you have to add the Isar package, which is just a Dart package and works in any context. And then you have to add the Isar Flutter libraries. And this one, as it says in this comment, contains the binaries for each architecture. the Isar core binaries. And unfortunately, Dart does not yet support bundling binaries. So if you want to use Isar in a Dart-only context, you go to the GitHub page to releases, choose your version, and download the binary for your CPU architecture. That's really cumbersome and annoying. But the good news is the Dart team is currently working on a feature called native assets. And it will allow Isar to download the binaries for you. And it should be super easy to use. You don't need the Isar Flutter libs library anymore. And Isar will just work everywhere. But I think it still takes a few more months to hit the stable branch.
Mm-hmm. Yeah, it sounds good. Awesome.
And maybe we should also talk about web support.
Yeah, actually, that was I said last question, but I actually wanted to ask this: does it also work on web?
Yeah,
because you've written that on Rust, and then
that's also a good question. And the Isar native library, the native backend library, does not work on web because unfortunately web does not support memory mapping and virtual memory, and that's what it relies on. But fortunately, we have the second engine, the SQLite engine. And if you compile to web, Isar will just compile SQLite to WebAssembly and use SQLite if you are in a browser. So it will work without you noticing any difference.
Mm-hmm. Oh, that's amazing. Have you considered to adding maybe particular web engine for Isar, like for example using IndexedDB, like because it's pretty popular on browsers, right? And it's also pretty performant.
I considered it, and fun fact, Isar version 2 contains an IndexedDB engine. The problem with IndexedDB is it has very different performance on different browsers. In Safari, it's pretty good. In Chrome, though, not so much. If you store a lot of data in IndexedDB, it gets super slow. And I struggled a lot with optimizing it and having the same feature set until I eventually decided SQLite and WebAssembly is the way to go.
Okay. So the benchmark that you showed, like, it's probably running on mobile, right?
Yeah, that's on an iPhone, yeah.
Yeah, okay. So it's probably nice to see the benchmark on web too.
That's a good point, yes. I didn't even try it myself, so it will be a surprise.
Yeah. So we'll see. But okay, fun part. So we now know about Isar, the architecture of it, and it's pretty fast. And we also know how flexible it is. Let's get into the fun part, do some programming.
Let's do it, yeah.
I think the best one is, well, let's get it started, see how we can implement that. The best is you show us the way that you are going to use Isar in your project. Let's go.
Cool. So what do we want to store?
Sorry, by the way, let's do it one more time. Your simulator is not here.
Oh, yeah, good point, sorry.
There you go. Let's go again.
Okay, let's do it. Should we maybe store a user object, like the users of our app?
Yeah.
Cool. So we create a user class and we give it a name. Now we give it a username and name and maybe, yes, the email and password, maybe not.
I see Copilot is helping you a lot here.
That's good for me. We need a constructor. Okay, so this is a very basic Dart class. And you only need two things now to make it work in Isar. So first of all, you annotate it with collection. Tables in Isar are just called collection. And then you have to...
I think generally in NoSQL databases, in many of the NoSQL databases, we call a collection is like containing a lot of documents, which documents have these, properties. So if people don't have this mindset of NoSQL, it's like collection, a bunch of document, and each document a bunch of property. So
That's
collection
exactly
in
right.
SQL word, that is translated to tables, rows, and columns.
Exactly. So the collection would be the table, and the individual user objects would be the rows in SQLite.
Exactly.
But one more thing we need to tell Isar is a unique ID, so it can identify individual objects. And in this case, we will just use the username, and we annotate it with @id, and that's it. So unfortunately, until we have static metaprogramming, Isar relies on code generation.
Code generation.
Yeah.
Okay.
So here it is, and dot pub build. I always forget this one.
I think it's build underline. Yeah, it's not build. It's
a not
build runner. I think.
Pub run. Yes, this looks good. Oh, did we not add the build runner dependency? We did.
No, you have to add it. Actually, Oh, it's there. It's there.
Yeah.
Build runner. It's there. Have you installed Flutter?
I had.
Get.
Okay, there we go. That's how I cheat usually. That's why I never remember the name. So Isar will now analyze our class, and if it thinks it's valid, it generates all this stuff in here. So first of all, it's the schema, so it knows what your class is. Then it builds a way to serialize and deserialize your object. And then down here, all kinds of static extension methods that make it easier to build queries. And one thing I'm often asked is, doesn't all this stuff make my app bigger and slower? And the cool part about Flutter is it has something called tree shaking. So only those methods that you actually use in your code will be included in your binary, and the rest will just be thrown away. So most of this will never make it to your production app.
Good. So I expect that you also consider nullability and like everything that Darts gives us. Yeah, okay.
For sure. Actually, you can freely change a field to be nullable or non-nullable, even if you already have your collection in production. So Isar will automatically handle previous fields with different nullability and give you a reasonable default value.
That's cool. Very cool.
Now, the next step is to open an instance. And like I said, Isar instances are basically, I think it's like a SQLite instance. And it's just a single database file containing multiple collections. So let's do that. It's isar.open. And then it expects you to give it the schemas you want to use. And they're always called the class name and then schema. So in our case, user schema and a directory. In a Flutter app, you would get the directory using something like path provider. You will see it later. But here we'll just use the current directory. And then in addition, you have some options you can provide. Let's take a look. You can give it a name if you want multiple instances. You can here choose the engine, either Isar or SQLite. This one is how big your database can be. It helps Isar optimize how much memory it allocates. Then new in Isar version 4 is you can encrypt your database. This one reduces the storage size when the app starts, and then the inspector, which we haven't talked about at all. One of my favorite parts.
Yeah.
But this is
I have two questions. If you go to open, actually it came to my head, which is interesting. So if you open again to see the properties, you'll see you said name for having different instances. Why would you want to have, so I have a scenario in my head. I just want to also say that. Why would you want to have different name for the exact same schema or exact same like database, let's say, like different instance of the same thing?
You can, for example, use it to model your data. I've seen it before. For example, if you have a chat app, you can use a new instance for every chat room. But that's not what I recommend, actually. I would only use instances if you have different configuration. For example, if you want to store sensitive user data in an encrypted database, but most of your app doesn't need encryption, then I would create two instances, one encrypted, one unencrypted.
One of the scenario that I came to my head quickly for that is when an app like adds a feature that you can have multiple user to log in, and potentially like user want to have different storage, but you can't really get rid of the storage. You need to keep them there. But if you log in with another, you are the same user probably, but using different username, or so it may happen, right? So you may log in with two different email into one app to get two different things, for example. I think this is also can be for that use case, right?
That's
so
a really
your
good
user
use case.
Yeah,
that's perfect.
Yeah, when you say name, actually this can I can send a PR and I can be a contributor to ISA. Okay, sounds good. Another one is about encryption key. This is super interesting. I think in the part that we mentioned about these users, potentially, I think we want to encrypt this database, right? I see this is optional. Do you do any kind of encryption like behind the scenes, or we explicitly need to pass an encryption key? And what is this encryption key, by the way? Like you said a string. Can I pass A just as a letter?
All of these are good questions. So by default, ISA does not encrypt your database. That being said, most OSs, especially Android and iOS, strongly protect app private files. And I think even encrypt them by now. But on Windows or Mac, for example, your database file will be somewhere where the user can access and read it. That encryption is quite slow. I mean, it's not about ISA. Encryption in general costs a lot of performance.
Yeah.
So the default is not to encrypt the database. Now, what does it do if you provide a string? First of all, the native ISA engine doesn't support encryption, so you would need the SQLite engine, this one. And it just uses SQL Cipher. And the reason why I chose this path is because SQL Cipher is industry standard, basically. And implementing encryption yourself can be dangerous. If you overlook some small detail, it can actually be a security vulnerability. And to your other question, if you just provide A, SQL Cipher will use your A string and make it into a secure encryption key. It will notice that it's too short, and it will generate a real strong key for you behind the scenes.
Okay. So then in this case, if I encrypt the database, on every read and write, the data will be encrypted and decrypted, or how does that work? Like you encrypt the entire database when you open and when you close, or or every read and write will be encrypted? Like
It's something in between. It has some
okay.
in-memory caches. So if you do, if you read the same object repeatedly, it will notice and keep it unencrypted. But decrypting the entire database would use a lot of memory. So
Of course.
it decrypts whatever it needs and then it throws it away afterwards.
Hmm. And another interesting one you showed me is compact on launch.
Yeah.
What does that mean? Like you shrink my data?
Yes, basically. So imagine if you write 1,000 objects in a row, and then they are also written to the database file pretty much in that order. Now, if you delete the first 900 objects, the database has a hole. There's a lot of empty space, and Isar will try to reuse the space later. But if you have, for example, on a really low-end Android device, if you have really little storage, you might want to reuse the space immediately. And then you can provide some conditions that Isar will check on app start. And if all of these conditions are true, for example, if it can free 50% of your storage, or if the file is bigger than 20 megabytes, then it will try to remove all of this empty space and basically rewrite the entire database file. It's quite an expensive operation, but if you really need the storage, it might save you.
I see. Interesting. And well, regarding inspector, then let's continue implementation, and then you show me what does it mean in inspector.
Okay. Like I said, we have an instance here. This was pretty easy. And
by the way, would you like clearly like create this instance in main before even you run an Flutter application, or would you do it differently?
If you have like a console Dart app, then this is probably fine. But as you can see, this doesn't have async or await. So it's a blocking operation. It will basically block your entire thread until it's done. And while it's quite fast, like 200 milliseconds or so, it will still cause jank, because in those 200 milliseconds, there will be no frames. So it's a good idea to use the open async. Yeah. Open async method.
Oh.
And not use it here, but in something like a future builder, where you can await the future that is returned by this. It actually returns the future. And in the meantime, still display like a progress indicator or something. So I wouldn't do it like this. I'd create a future builder, a stateful widget, and then create a new instance while showing a loading screen or something.
Makes sense. Makes sense. Oh, sounds good. Let's then. This is now going to open an Isar. You do have a counter app, so we talked about this basic. Maybe we should fall back to the counter app and see the other implementation. So I think we can. We can. Let's do it.
One thing I'd like to show here is, because we have so many properties in the counter app, so basic. I'd like to quickly show off how queries work. So you do Isar,
let's do that.
Dot, and then users, because your class is called user, and then you just say where to start a query. And if we disable Copilot for a second.
Yeah.
Okay. You see all these generated query methods. Email between, contains, ends with. All of these things Isar knows it can do with the specific type of your property. It generates methods. And the cool thing about this is you can not spell the property wrong. You cannot use a query method that is unsupported for integers, for example. This one only is allowed for strings. And the second cool part is it statically checks your query. For example, if we say and again, it doesn't work because this is an invalid query. It only allows those properties that are allowed in this specific position. For example, we can do another comparison, and then we can use something like or and again. But it will statically check that you did make a mistake.
Awesome.
Then we can use find all to find all the matching objects. But let's head over to the counter app, which is much simpler.
That was very nice. Yeah.
So here again, we have a collection, and it's just called count. It has an integer ID and a step number, basically how often you press the count button.
Yep.
And here we're in a Flutter app. So we actually have to give Isar a real directory because most operating systems have specific requirements where you're allowed to store data. And since Isar stores a file on your disk, you have to tell it where it's allowed to store it. So the first part, which I always forget and screw up, is this one, to initialize Flutter and to be allowed to use this method, which is provided by a package called path provider. And what it does is for every operating system or platform you run on, it gives you a valid directory where you can store the data. So we get it. This is not needed actually. We get a directory and we provide it to Isar, and then we start the app. In this example, again, we did the hacky approach of initializing Isar in the main method. If you have a production app, don't do it. Create it. Yeah. Go the extra mile and create a future builder.
Would you? So the directory is required. If you need to always get application document directory for mobile app, especially, why would you do that as a default value there? Because it's just, to me, it looks like it's because of another dependency for your package, right? Probably.
Yeah, and because this package is a Flutter only package, and I want Isar to work in the Dart context. So yeah.
Okay, makes sense.
I wish there was a better way. I tried all kinds of things. I even tried getting the path directly in Rust, but it also caused issues on old Android phones. So unfortunately, you really have to provide the directory, and it's not automatic.
Yeah. Okay, so good.
Then we head into the main app, and it's just a material app with an app bar, some text, and a button that calls increment counter. This is probably familiar because I stole it from the Flutter example project.
Yeah.
And increment counter gets interesting again, because one thing we didn't talk about is transactions. And transactions are a way to look at the database state in an atomic way. It means Isar supports multi-threaded access and parallel read and write, but often you want a consistent view of the database so it doesn't change basically while your method is running and have inconsistent state. So if you run something inside a transaction, either read or write transaction, the database will not be influenced from somewhere else in your code. And for write access to the database specifically, it is required to have a transaction. And the reason is writing is rather heavy and costs a lot of performance compared to reading. Reading is super cheap, but writing can be heavy. And what I've seen people do is have a for loop and writing in that for loop without transaction. And if Isar would create an implicit transaction, it would create hundreds of transactions. So I made write transactions required. So you're more likely to put the for loop inside the transaction right here. So Isar only has to create one transaction.
Yeah. Okay, that's nice that you thought about that too. It's very nice. So does it mean also, like when you say atomic way, so if this transaction fails, so you kind of roll back to the previous state of, the database and what it was, right?
That's a very good
you
point.
kind of follow that. Mm-hmm.
Whatever goes wrong inside this closure, inside this function, all the things you've done to the database inside it will be rolled back to the state before the transaction.
Fine.
This
Nice.
allows you to, if you want to delete a user and also delete all his comments, and something goes wrong while deleting the user, then you would have often comments floating around, for example. And this makes sure that your database is, after the transaction, still in a valid state and you don't have any weird things floating around.
Yeah. Mm-hmm. Nice.
So here we use the put method, and what it does, it just inserts whatever object you give it here into the database. And
Potentially also updated, right? Usually put
Yes.
is like insert update.
so the first parameter here is an ID. If we go back here, it's the ID and the number of steps or clicks we have done. So as an ID, you could either use whatever ID you want here, or you use the isar.autoincrement, and it will look at your collection, find out the largest ID you've ever inserted, and increment it by 1. So you will get an ID that has never been used before, because in this case, we don't want to override the existing counts. We just want to add one more. If we used an ID that was used before, then the existing object would be overwritten with our new one here.
Mm-hmm. Yeah. Okay. So this operation right now, let's if you want to translate it to simple English, means now you open a transaction, then you start adding a row here, which is a count, and you add one more to that collection, which is the counts collection in this case. So in this case, if I have like a for loop, let's say if I click 10 times, I'm going to have 10 records in my collection. Am I right?
Yeah, let's simulate what happens here. So
Yes.
if we just start the app, our database looks something like this. Just an empty list. And then as soon as we hit the button for the first time, it will start a transaction, look at the existing IDs, there are none. So it will set auto increment to 0, and it will add a count object with ID 0, count 1. Then if you hit the button another time, it will find the existing object, increment the ID by 1, so the new ID is 1, and the count is still 1.
Yep.
And so on.
Exactly.
This happens a bunch of times. The ID gets updated every time. And now that we hit the button 5 times, the database looks something like this. 5 count objects from 0 to 4, each with a step value of 1. We could have a super increment button that has a step value of 10, and we could increment the counter by 10 every time, for example.
Yeah, interesting. So I guess now this is where I wanted to ask my question about inspector. Inspector means that I can explore my database schema as well, or it's just for debugging?
It is mainly for debugging. Unfortunately, it isn't implemented for Isar version 4 yet, so I can't show you a live example.
Okay.
But we can head to the GitHub page again, because I think there's a screenshot. It looks something like this.
I see.
On the left, you see the different the different collections you have. You see how many objects are stored, how much space it uses. down here, you see the different instances. If you have multiple, you can choose between them. And then up here, no, let's start here. Down here, you see a list of all the objects you can scroll. As you can see, it's paginated, so you can scroll through all the contents in your collection. And then if you try to find a specific object, you can use the query builder up here to build queries and in debug mode, see what is in your database. And the coolest part, you can even edit your objects, as you can see right here. Here I changed the content to test. And if I hit save, it updates the app immediately. And this allows you to change the database content and see how it affects your app in real time.
Nice. I think, can I then in this inspector at the end, when I made my query groups, whatever, then copy the code as well?
No, you can't, but that's an amazing idea.
I was actually thinking, because it happens, right? So you want to make a query. It just happens that you play around with inspector. Even for SQL, I remember I always had my something open. Like when I was working in MySQL, I had my phpMyAdmin somewhere, always playing around, get the query working, and then copy and paste it somewhere.
That's an amazing idea. I will definitely implement it.
I give you so many tips today, I think I'm just joking. But this is a nice feature. I think it's going to be very useful for many devs playing around, especially for, like, let's say, complex databases where you have so many objects, so many collections. It's hard to get your head around of queries, what I want to do. And also it's very hard to get it right.
Yeah, so, and to see what is going on. For example, if you have a background isolate that cleans up your database occasionally, how do you check whether it works? You can do so right here, and it will update in real time if your cleanup works correctly.
Yeah, fantastic. Well, this is cool. So thank you very much. Let me just ask you my final question, and then ask you to give me some advice afterwards, and then finish this show. Yeah. So I see you have a way to add different adapters somehow, like native SQL, or you call it engine, to Isar too. Is there any way that you think at some point later you may even add an adapter to work with PostgreSQL, MySQL, and other ones, like creating a ORM kind of package?
I think so, yes. I think it would be really cool. Adding a new engine or adapter is a lot of work, and a lot of testing is required because databases are really critical to be tested well. So the only thing that stopped me is the time. But it's definitely on my roadmap, and I think about it a lot, because I think it would be super cool to just flip one property and have your code work on the backend with a real backend database. So this is an awesome idea, and I actually got it as a feature request multiple times, but I just haven't found the time to really do it.
I guess one thing I can encourage whoever is watching right now this video, I think one thing that is encouraging or motivating authors of these packages right now, like Simon, please go ahead to GitHub. There is a sponsor probably link, or somewhere else. I'm sure Simon has a website or something that you can contribute also financially, because it just helps Simon to figure out, maybe thousands of people are interested and they're contributing every month, I don't know, $5, and then I get 5,000. Maybe I can just free up my time and work on this, I don't know if this is something that you are passionate about or you want to do it, Simon, but at least this gives some motivation, that people are also interested to support you. Please go ahead and do that, because...
Thank you. But just as much as financial support, I really love to see people using Isar, people showcasing their apps, opening issues, opening pull requests, and so many people do it. And it makes me really happy and is the one thing that motivates me every day to push another unit test.
That's fantastic. Well, then, thank you very much. If you want to give us, as always, the last words like tips, tricks, anything about Isar that you may want to share right now. I know that we just touched the surface. There are probably a lot more to Isar. Hopefully, you will come back one more time and we go through the details of Isar. But right now, if you want to tell us any tips, tricks, or anything about Isar, just go ahead. The stage is yours. Your last words.
Oh yeah, I'd really love to overhaul the documentation and use, for example, ZAP to have real-time examples. And one thing I noticed is, especially for beginners, the documentation is too complex. And I sometimes fail to see those issues because for me it looks obvious, but then I see many people struggle with a specific piece of code. And it would be really helpful if you could just open issues if something is too complex, if you have questions, open pull requests to make it easier. So that helps a lot, and I really appreciate it.
I will write down all the GitHub repos, Simon's Twitter, and everything in the comment below. So reach out to him, please open issue. And as he said, it's motivating to see that you are actually using and struggling.
Yeah.
And he sees that, he can fix it for you, but he needs to see it as well, Very nice, Simon. I never get tired of talking to you and pair program with you. You need to promise one more time come back and go into the details of implementation, maybe more complex. Yes, I always enjoy talking to you on this show, and I think everyone else will do. Thank you very much. And with that said, then have a good day. See you next time.
Thank you so much for having me. Have a great day.